Okay, polynomial test review. Number one, simplify. So this is an ideal situation, right? Anytime you're simplifying, we're just combining like terms. You just have to be sure that you're combining like terms, meaning the variables that have the exponents. That's what you're combining. So here we have to distribute the negative. So it's going to make this plus. It's going to make this minus. It's going to make this minus. So now we drop the parentheses, right? We no longer care that this is minus because it's been distributed. We drop the parentheses and we just add everything. Or we're combining like terms basically. So the biggest degree is x to the fourth. X cubed, there's only one. So plus 5x cubed. X squared, there's 1, 2. So 6 minus 2. 6 minus 2 is actually negative 6 minus 2, right? Because we're combining like terms. So this is going to be negative 8x squared. Then regular x's, or single x rather, x to the first power. So we have 1, 2. So negative 3x minus 3x is going to be negative 6x. And there's no constants. Okay. Number 2. Simply multiply. Okay, here, this is going to be 2x plus 1, that binomial, 4 times, right? You cannot just apply the 4 to each of these. That's not how this works. Right, what this is saying is 2x plus 1 times 2x plus 1 times 2x plus 1 times 2x plus 1, right? 4 times. And now we can use FOIL, distribute. So this would be 4x squared plus 2x plus 2x plus 1. So that is, combining the two middle terms, we're going to get 4x squared plus 4x plus 1. Okay. When I FOIL out the other two, right, it's the exact same thing, like literally the exact same thing. So that's going to be 4x squared plus 4x plus 1 as well. And now we do one last FOIL. Actually, this wouldn't be FOIL. This is triple distribution, basically. So that means 4x squared times 4x squared is going to be 16x to the fourth, right? Because when you multiply common bases, you add the exponents. This is going to be 16x cubed. Then 4x squared. Okay, now the middle term has to get distributed to everything. So it's going to be plus, we're doing a different color maybe, so you can see it. 16x cubed. 16x squared. 4x. Okay, then the last one. This is nice because look, it's just 1 times everything. 1 times everything. So that means plus what? 4x squared plus 4x plus 1. Okay. This is going to be, so we're combining like terms now. We're actually running out of room. So this is going to be, we'll erase the last problem. Combining the like terms, we're going to get 16 x to the fourth x cubed plus 32x cubed x squared. 4 plus 16 plus 4. 24. X to the first power is 8x. And then the constant plus 1. So here we go. Okay. Number 3. Look, I'm going to erase this so I can have some room. Okay, this is going to be n plus 1 squared, right? So here, if you've followed my channel at all, you know how I do squaring a binomial. It's my trick. So n times n squared, 1 times 1, 1, 2 times n times 1. So 2n. And this is going to be times 3n minus 4. Right, times 3n minus 4. Okay, this is going to be 3n cubed plus 3n plus 6n squared minus 4n squared minus 4 minus 8n. Combining like terms, we're going to get 3n cubed. 6 minus 4 is 2. So 2n squared. 3 minus 8 is negative 5n. And then the constant, negative 4. Okay. Number 4. Factor completely. All right. It's 4 terms. So my instincts are just split it down the middle and see what happens. So GCF of the first 2 terms is going to be a squared. And then for the coefficient, we could take out a 4. So left behind is going to be 2a. Because if I put it back, if I combine these, it'll be 8x cubed. Then minus 3. Okay, right hand side, the 2 on the right, the 2 terms on the right. This is a negative, so I'm going to take out a negative for sure. So negative 25. And left behind is going to be 2a, right? Because 2 times 25 is 50. And then minus 3. 25 times 3 is 75. So notice, right, the part inside the parentheses match. So that means that's a factor. 2a minus 3. That's a factor. And then the parts in black, the outside parts, we just group those together. So 4a squared minus 25. Minus 25. Okay. 4a squared is a difference of squares. You have to be able to train yourself to see this. Right? You got to be on the lookout for perfect squares, especially in these binomials, right? This is really 2 squared, and this is really 5 squared. What I'm saying is this is going to be 2a squared minus 5 squared. And this 2a is your a, basically, and 5 is your b. So a difference of squares says if you have a squared minus b squared, you can rewrite this as a plus b, a minus b. And we've already identified our a's and b's. So this is going to be, so final answer, putting it all together, it's 2a minus 3 in red. And then this part's going to be 2a minus 5, 2a plus 5. So all three of these are going to be multiplied together. It's the factors, basically. Okay. Okay, number 5, factor completely. So here, the GCF is going to be x. Left behind is 108. X squared minus 147. Okay, so coefficient-wise, we could take out a 3. That's the number that jumps out at me, right? 108 is divisible by 3. And so is 147. I wonder if 108 is divisible by 7. So 7 goes into 10 once. 38? No, it's not. Okay, so let's take out a 3. So if we take out a 3, we're going to leave behind 3 goes into 10 3 times. 9. 1 left over. Bring down the 8 is 18. 3 goes into 18 6 times. 3 goes into 147. 4. That's 12. Minus 14 is 2. Bring down the 7 is 27. So this is going to be 9. So 36 and 9. Difference of squares, right? 36 is a perfect square. 49 is a perfect square. So this means 6 squared x squared minus 7 squared. And this could just be rewritten as 6x squared minus 7 squared. All right, so that's a difference of squares. So our final answer is going to look like 3x, right? Because that's the first factor, the GCF. And then these two smaller ones, right? Because this is your A and this is your B. So 6x minus 7, 6x plus 7. All right, difference of squares comes up a lot. Like, so you might as well just go ahead and just start trying to recognize it. All right, number 6. Okay. Notice, so it's a trinomial. The thing that pops out at me is that how are the powers related? Well, the middle one, right, the second term, 3, it's half of 6, right? It's half of 6. So this is what we call a quadratic form. You can factor this in the same fashion that you would any quadratic. So what am I saying? I'm saying let's just consider if this was squared and this was just an x, right? If this was 2 and this was just x, right, to the first power. How would you factor this? That's the question. Because it will factor exactly the same. So there are a couple different methods: quadratic formula, the AC method, slide and divide. Personally, I like to multiply 8 times 2, which gives me negative 16. Factors of negative 16 that add up to negative 15. So 1 and 16. Can I make a 15 out of this? Yes, I can, because it's negative. One of them has to be negative. Well, which one? Because this is negative, the big one's going to get it, right? The big one gets a negative. So this means the factors drop right in, right? Plus 1, negative 16. And then, again, this was x squared. So, like a quadratic, right? We'd just drop in the x's, and then we'd be good. But that's not the case, right? This is actually x to the 6th power. So what I want to do is the middle term, that's the power that goes on the x's. X cubed, x cubed. Then because we multiplied the 8 in the beginning, we have to divide the 8 back out. Simplify where we can. This is going to be 2. And then the 8 here, right, can just swing up and be the coefficient. All right, and then that's because if we multiplied this by 8, right, to try to clear the fraction, the 8 would be here, and then the 8 would cancel on the 1/8. So our answer, our final answer, is going to be 8x cubed plus 1 x cubed minus 2. Okay. Right away I'm noticing that 8 can be rewritten as a cube. And this piece here, we'll call this a sum of cubes, right? Because 1 cubed is the same as 1. And 8 is equal to 2 cubed. So what this is 2x cubed plus 1 cubed. All right, there's a nice property that says, what's it say? A cubed plus b cubed can be rewritten as a plus b, a squared minus ab plus b squared. Okay, the way I remember this is plus minus plus, right? Plus minus plus. That's a sum of cubes. Sum of cubes. Plus minus plus. That's the way I remember it. That's the pattern. And then AB, A squared, AB, B squared. Okay, with that being said, this is my A, this is my B. So I'm going to get 2x plus b, and then 2x squared, so 2 squared, minus a times b, that's nice, 2x, and then plus b squared, which is just 1. Okay. This can be rewritten as 4x squared. So 4x squared minus 2x plus 1. Can that be factored? Negative. So it's going to be 4 minus 16. 4 minus 16. Okay, so this can't be factored anymore, right? It's going to be complex. It's going to be complex. So our final answer, right? I quickly did. I thought about the quadratic formula, and I looked at the discriminant, the part under the square root. Because if that was positive, then this might factor cleanly. You never know. But it's negative, so it's going to be a complex number, so it's not going to factor cleanly. So final answer, x cubed minus 2. Right, this can't be factored anymore. 2 can't be rewritten as a cube. 2x plus 6. Yo, I put b. Okay, so maybe you caught this. It's not a plus, I mean, it is a plus b, but in this case, b is 1. Caught it. Caught it. And then 4x squared minus 2x plus 1. Okay. There it is. What number are we on? Number 6. That's what it would, that's what number 6 would be. So factor completely. There it is. Let's go. Okay. It's curious, how come number 7 is factored completely as well? They couldn't just say 4 through 7 factor completely. Okay, so this is going to be difference of cubes. Difference of cubes. Right, 125 is really 5 cubed. 8 is really 2 cubed. And x to the 6th is really x cubed squared. Okay. So I wonder, all right, so how can we write this? Right, because this is being a power to a power. Can't just factor it out. Right? It doesn't work that way. It doesn't work that way. What does that mean? Okay. I think I got it. I got it. I got it. So x to the 6 is really x squared cubed. So now, in a sense, I can factor out the cube from each of these, right? Because this is going to be 2x squared, right? That's going to be cubed. Right? Because think about it. If I apply the cube, right, that'll be 2 cubed and then x to the 6, because you have to multiply the exponent. So we're good there. Minus 5 cubed. And a difference of squares. So a difference of squares is just like, a difference of cubes is just like a sum of cubes. The only difference is the pattern, the symbol, the operation pattern, right? Here, up here we had plus, minus, plus, right? That's the pattern of the symbols. Difference of cubes, we have a lot of room over here. A difference of cubes, the pattern is minus, plus, plus, with the same letter structure. So this is my A, this is my B. So final answer, I don't know if it's a final answer, but the next answer for sure is going to be 2x squared minus 5. And then a squared, which is, so 2x squared squared. So 4x to the 4th plus a times b. So it's negative, or so it's 5, right? Because I'm not counting the negative. It's just 5 is b. So 5 times 2x squared, which is 10x squared plus b squared, which is 25. Okay, the first binomial is good. This trinomial, I wonder if it can be factored. Oh, you can't even see it. There you go. Move it up. My fault. All right. So let's think about it. Multiples of 100, because 4 times 25 is 100, that add up to 10. Multiples of 100 that add up to 10. So we got 1 and 100, 2 and 50, 3 and nothing, 4 and 25, 5 and 20, 6, 7, 8, 9. Wait a second, that's not right. It's 5 and 20. 5 and 20. And then 10 and 10. So nothing that adds up to 10. Right? There's no way to make 10 out of any of these. So I think it's safe to say that that is the this is the factored form. It almost looks like it would, but maybe it will. Actually, oh, I think it can. I think it can. I saw it at the last second. Can this be? Say it ain't so. 4 is really 2 squared. And then 5 is really 5 squared. So right now, this is my A and this is my B. 10x squared is really what? A times B? A times B? No, it cannot. No, it cannot. Had that been 20x squared, I feel like I could have done something, but I cannot. Okay. We'll leave it at that. I may be wrong. Okay, number 8. Solve. The way we solve this is by factoring it, or at least attempting to factor. So we split it down the middle. GCF is going to be, take out an x to the 4th. What's left behind? X squared minus 4. On the right hand side, this is negative. GCF is going to be negative x. Left behind should be x squared minus 4, but let's see. This is going to be x squared. Right, x squared. Because if I put it back, I get x cubed. And then minus 4. But negative and negative is a positive. So 4x. Okay. Because the parentheses match, we know that's a factor. So x squared minus 4 is a factor. And then the black parts. X to the 4th minus x. Okay, both of these can be factored. So the red one first is a difference of squares, right? This is really 2 squared. So that's going to be x minus 2, x plus 2. And then here in the second one, the x fourth minus x, we can factor out the GCF, which is x. So I can take out an x. And left behind is x cubed minus 1. 1 can be rewritten as 1 cubed. And there's a difference of cubes again. So let's put it all together. The x is a factor for sure. And then this x cubed minus 1 cubed business is going to be, right, a difference of cubes is going to be, so x is A, 1 is B. So x, difference of cubes is minus plus plus. So minus 1, and then x squared plus x, right, because AB, and then B squared, which is 1. X squared plus x plus 1. Okay, that's not a clean factor. It can be factored cleanly. So there we go. There we go. Okay. And just to point it out, right? This is a 6th degree polynomial, so there should be 6 roots, right? Fundamental theorem of algebra tells us that there will be 6 roots. So we have 1, 2, 3, 4, and now this is a quadratic. If you use quadratic formula, you're going to get 2 complex numbers. So this would count as 2. So that's definitely 6. So it's good. Oh, technically we're solving it for 0. So that means we have to set each of these equal to 0. So we have to figure that out anyway. So this is going to be, so that's the factored form in the box. But because we're solving it for 0, we have to set each of these terms equal to 0. So x is equal to 0. X is equal to -2 and +2. So we'll call it plus or minus 2, right? That's 1, 2, 3 roots already. And then x is equal to +1. And now we need to figure out, because we need to solve it, right? So this quadratic that I said would be complex, we definitely have to factor this, and it's going to be the quadratic formula. So minus b, which is -1, plus or minus 1 squared, which is 1, minus 4 times a times c. Both of those are 1. All over 2 times a. Okay, so simplifying this is going to be -1 plus or minus 1 minus 4 is 3. -3. So √3 and then I. We could throw the I in front just so in front of the √3 and then all over 2. So there are the next 2 roots. X is equal to -1 plus or minus I √3 all over 2. You could put the I in the back of the √3 and it's the same thing, right? It's all multiplication. Okay. Number 9. In behavior. Determine the end behavior. So what we're saying is in behavior, when you have a graph, like for instance, I'll use this picture as a reference. So the end behavior is going to mean the arrows. What direction are the arrows pointing? So like for instance, this guy right here. This would be an even number function, right? X to some even number. 4, it's not 2 because it's not a parabola, but 4, 6, 8, some even number. And that's based on, because these are both pointed up, right? They're both pointed up. This would be a positive x even number. So we can call it x to the even power. X to the even power. And because they both open up, it's positive. Had this been negative, it would have been even, and they would have been facing downward. They would open downward. So with that being said, number 9, the end behavior so this is a even number. So they're going to both open up or both open down. Which one is it? Well, that's when I look at the symbol and it's negative. So it's going to open down. So the end behavior is going to be downward. It's like, what happens in the middle? I don't know. I mean, I could figure it out, but the question's asking for end behavior. What's the end behavior of this function doing? Well, they're going to open down in the same direction. Same direction because it's even. Had this been an odd number, right? It's a natural question. If this was odd, so right now this is even. So odd, like 1, 3, 5, 7. So odd, positive, looks like this. Odd, negative, right? This is odd, and this is positive. Odd, negative, it's going to open up and to the left and then down and to the right. And then whatever it does in the middle is whatever it does in the middle, right? But strictly in behavior, that's what we're saying. What are the tails doing? The arrows doing? Okay. We're almost there. Divide using polynomial long division. Okay. I don't have no room. All right, I'm going to write it over off to the side under number 11. So this is going to be, I don't have any room. Okay. X squared minus 2x plus 1, right? This is the divisor. Are all the x's there in descending order? Yes. Yes. Inside the box is going to be the dividend, this part. So 8x to the 5th. So step 1 is make sure that they're in descending order and they're all there. Right away, there's no x fourth. So I have to put plus 0 x to the 4th. Plus 3x cubed plus 2x squared plus x minus 1. Okay, we started going through our long division. I look at the first terms only. What times x squared gives me 8x to the 5th? And that's going to be 8x to the 4th. No, that's going to be 8x cubed. Because when you multiply, you have to add the exponents. 3 plus 2 is 5. So this is going to be, so now I have to distribute this 8x cubed to all 3 of these things over here. So this is going to be 8x to the 5th. Right, that's by design. We've designed it that way. It's supposed to match. Then negative 16x to the 4th plus 8x cubed. When we add, we're going to get 0. Actually, we need to flip the signs because we need to subtract and then add. So we have to subtract these. So negative, this becomes plus, this becomes negative, right? You have to flip all the signs. right? So now when I add or combine, 8 minus 8 is 0. 0 plus 16 is going to be 16x to the fourth. And then 3 minus 8, negative 5x cubed. Then we bring down the x squared, so 2x squared. I'm going to actually continue the work right here. So this is going to be 16x to the fourth minus 5x cubed minus 2x squared. Okay, how many times is, what times x squared gives me 16x to the fourth? 16x squared. So plus 16x squared. Now, again, I have to distribute that 16x squared to each of the three divisor terms. So it's going to be 16x to the fourth, as expected. Then times negative 2x will be negative 32x cubed. And then plus 16x squared, right? Because times 1. All right. We need to flip the signs. So minus. This becomes plus. This becomes minus. When we combine, we get 0, right? Because 16 minus 16. Negative 5 plus 32. 30 minus 3, 27. Positive 27 x cubed. And then negative 18 x squared. We bring down the x. We analyze again. X squared times what gives me 27x cubed? It's going to be 27x. So plus 27x. When we distribute, we're going to get 27x cubed. 27x cubed. 27 times negative 2. Negative 54. X squared. And then times 1. Plus 27x. We have to flip the signs. This is going to be negative. This is going to be plus. It's going to be negative. When we combine, oh, you can't see it. I should have looked up. All right, when we combine, we're almost there. When we combine, we're going to get 0. Negative 18 plus 54. So it's going to be a positive number. 54 is bigger. And so we subtract. So 54 minus 18. It's going to be 44. 44 minus 8. 40. 36. So 36x squared. And then x minus 27 is minus 26x. All right, last step. We got to bring down the negative 1. So then minus 1. Okay, x squared times what gives me 36x squared? It's going to be 36. So plus 36. Now 36 times each of the divisor terms, we get 36x squared. 36 times negative 2 is negative 72x. And then times 1, just be 36. Okay, when we combine with when we have to flip the signs now. So this is going to be, wow. This is going to be negative plus negative. So 0, that's nice. Negative 26 plus 28 can be positive. Positive what? 72, 62, 52, 52 minus 6. 50 minus 4. 46. 46x. And then negative 37. All right, can't go any more, so that's the remainder. So the remainder, or I guess final answer, is going to be 8x cubed plus 16x squared plus 27x plus 36, then plus 46x minus 37 over x squared minus 2x plus 1. That one's pretty intense. That one's pretty good, though. It's pretty good. Okay, number 11. For the polynomial below, what is the highest degree term? So the highest degree term is the second term because it has the biggest degree. So negative 7 x to the 5th. That is the highest degree term. Now, the highest degree is the degree on the term. So the degree would be 5, but the highest degree term is negative 7x to the 5th. That's the term. Okay. For the polynomial below, what is the total number of roots? Okay, well, we know fundamental theorem of algebra says that this will have 6. Right? It will have 6 roots. Whether they're real or complex, whatever the case, it's going to have 6 roots. Does it actually? Who knows? But it definitely has 6 complex numbers. Now, it could have less than 6, right? If you subtract it could have 4, it could have 2, or it could have none, right? It's even, so they're both going to open up. So this could be very well above the x-axis for sure. Could be. This one's not actually. I mean, you'll learn techniques later, but at a glance, you could tell. Okay. Refer to the graph below for A and B. So let's erase the tails. Okay. Is the degree of the function even or odd? What you think, people? Even. Even, Steven. Because, again, they both open up. So that's definitely even. Because they're both going in the same direction. They're both going in the same direction. Find an equation for the graph. Don't forget to find A. And it even gives you the roots. How nice. Negative 1, 1, and 2. So let's think about that. The roots are x equals negative 1, x equals 1, x equals 2. So since those are the roots, the factors are going to be x plus 1, x minus 1, and x minus 2. Okay, now we can FOIL these out. We can FOIL these out. Or distribute, however you want to look at it. But x times x. Oh, look. Technically, x plus 1, x minus 1. That's a difference of squares going in reverse. Look. Difference of squares going in reverse. A squared minus b squared. I can do a plus b, a minus b. Do you see it? Do you see it? A plus b, a minus b. So it's a difference of squares in reverse. This means x squared minus 1. That's what that means. I'm going to multiply this by x minus 2. All right, there's no trick here. You have to FOIL this one out. So this is going to be x squared times x is x cubed. X squared times -2, -2x squared, minus x plus 2. And look, it's already in descending order. There it is. Technically, we got to find a, right? The thing it said not to do, I just almost forgot it. So it's going to be, so what this is saying is y is equal to a times all of this, right? A times all of this. So if I pick a point, let's pick a point. I only see one nice one, really. That's right here. So this is going to be, well, this is a half number. So this is going to be 2.5, or which is 2.5. 5 halves. Right, because this is 5 halves, and then up 2. So when x is 2, no, when x is 5 halves, y is 2. So this means y is going to be 2. And x is going to be 5 halves. Wow. All right. Let's do the math on this. So this is going to be, I'm really running out of room. Okay, so 2 is equal to a 5 halves squared. Square the top, square the bottom. 25 over 4 minus 1. And then 5 over 2 minus 2. We got to solve for a. Okay, this is really 4 over 4. That's what 1 is. So this is going to be 21 over 4. So 2 is equal to a 21 over 4. And then 5 halves minus 2. 2 is really 4 over 2. So that's going to be 1 half. So it's multiplication, right? Times 1 half. So this is going to be 21, or 2 is equal to a 21 over 2 times 4, which is 8. When we reciprocate, a is equal, right? Because 8 over 21 cancels. 8 over 21. So it's going to be 16 over 21. A is equal to 16 over 21. Just making sure that's correct. Looks right. You can bounce it off the key and let me know what you think. But basically, you're going to put this 16 over 21 back up over here in place of the a. All right, so 16 over 21. You probably didn't even need to FOIL it out, to be quite honest. Like, you could have just maybe left it here. Once you had the roots, you didn't have to FOIL it out, actually. Now that I think about it. Okay. All right, 14. Given this, 2x cubed minus kx plus 5 divided by x plus 3. Find the value of k so that the remainder is 10. Okay, easy money. Check it out. What we're going to do, so 2x, so I'm going to do synthetic division. Notice there's an x squared missing. So I'm going to say 2 plus 0 minus k plus 5. Positive 5. All right, we're going to do synthetic division with x plus 3. That means x is equal to -3. That's the number that goes in the box when you do synthetic division. Okay, we start running through the process. And what's it saying? It's saying that we want a remainder of 10. So I know that there needs to be a 10 right here in the end. Okay, so let's go through a little bit. This is going to be bring down the 2. -3 times 2 is -6. When we add, we get -6. When we multiply, we're going to get positive 18. Positive 18. Okay, when we add, we're going to get k, negative k, plus 18, right? Because you can't combine a variable and a number, so it's like a polynomial. Then when you multiply, you're going to distribute, right? So this is going to be positive 3k minus whatever 18 times 3 is. 18 times 2 is 36. 36 plus 18, 46. 46 plus 8, 54. Okay, let's think about this for a moment. This is saying that when I add this, 3k minus 54 plus 5 must equal 10. So this is going to be 3k minus 49 is equal to 10. Plus 49 plus 49. So 3k is equal to 49. So k is going to equal to 49 thirds. Just doesn't seem right. Doesn't seem right, but we have to trust it. What number are we doing? Okay, so let's just double check. 2x, 0x squared, negative k, x to the 1, plus 5. Yeah. Unless 18 times 3 is not 48. Oh, wait. I don't think it is. 18 times 3. 54. Okay. So it's going to be 3 times 18. So negative 54. I haven't said 54. Why did I write 48? What's going on here? What the heck? Okay. So then when you add, it's definitely 49. Okay. I mean, if that's what it is, that's what it is. This value for k will give us a remainder of 10. What if we come at it in reverse? Let me just think real quick. So this is definitely going to be negative 18. Right? I know I needed 10 to be the remainder, and we're adding. So does that mean 5? So this is going to be 5, right? Because 5 plus 5 is 10. That means 3 times something needed to be 5. So negative k, this is positive, plus 18, right? Negative k plus 18. That number would have gone right here. This times 3, negative 3, should equal 5. So this is positive 3k, negative 54 is equal to 5. Yeah, it checks out. I mean, it's going to come out the exact same. So Actually, it's almost the same. Not quite, actually, because if I add 54, I'm going to get 59. Right, negative k plus 18 times negative 3 needs to give me 5. Because 5 plus 5 is 10. So 59 over 3. It's 59 over 3. Where did I get 49 from? Oh, because minus 5, minus 5. Oh, I didn't do the 10. I didn't do the 10 part. Okay. Yeah, don't pay attention to this on the right. Don't pay attention to that on the right. 59 thirds. That's what it's going to be. 59 thirds. I'll stick by that one. I'll stand by that. Okay. Where are we at? 15. Find all the zeros of the function with one of the zeros at 5. So x equals 5 is a 0. X equals 5 is a 0. So this means if x equals 5 is a 0, we want to find all of them. So there's going to be 3. So I need to find 2 more. So if 5 is in the box, and they're all in descending order, the coefficients 3, negative 14, negative 3, negative 10. Synthetic division, bring down the 3, we multiply, we get 15. We add, we get 1. We multiply by 5, we get 5. We add negative 3, we're going to get positive 2. Times 5 is 10. We get 0. And this is x squared plus x plus 2. Okay, I need a factor 3x squared plus x plus 2. So I look and see 3 times 2 is 6. Multiple is 6 that add up to 1. 2 and 3 is what jumps out at me. But is this possible, though? Because they're both positive. They're both positive. So 2 times 3 would be 6. But then there's no way to add 2 to 3 to make 1. Right, it's not possible. So that means it's going to be complex. That's what that means. So if I do quadratic formula, minus 1 plus or minus 1 squared minus 4 times a, which is 3, times c, which is 2, over 2 times a. 2 times 3 is 6. So simplifying this, I'm going to get negative 1 plus or minus the square root of 2 times 3 is 6, times 4 is 12, 1 minus 12. 1 minus 12 is negative 11. So 11i. All over 6. Right, is that true? That's not, actually, that's not true at all. What did I say? That's going to be 1 minus 4 times 3 is 12. 12 times 2 is 24. 4 times 3 is 12. Times 2 is 24. 1 minus 24. I don't know what I said earlier. 1 minus 24. 1 minus 24 is 23. So 23 I. 23 is prime. So there are my two factors. Right? 12 times 2 is 24. Yeah. So the zeros are x equals 5 and then x equals this over here. Okay. Number 16. Write the polynomial function of least degree that has the given zeros, -2, 2 plus I. Okay, so immediately, I know another root, like by default, 2 minus I, right? That's gonna be another 0, right? Because I's always come in pairs. They always come in pairs. So they're conjugate pairs actually, which is actually kind of nice for the multiplication wise, that is. So this is gonna be x is equal to -2. X is equal to 2 plus I, and x is equal to 2 minus I. Okay, if I want to I want to combine these. So it's going to be, I'm going to work down in 17 space and then I'll erase it. Actually, you know what? Let's do it over here. So what I'm saying is we're going to turn these roots into factors. X plus 2. So this is going to be x minus 2 minus I. X minus 2 plus I. All right, think of it like this. Can we think of it like that? Now that I think about it. No, we cannot. Don't disregard that. Don't think of it like that. Okay. We can, however, start just factoring this guy. Not factoring, distributing. Right, x times x is x squared. X times -2, -2x. Then plus xi. I have a feeling that's going to cancel later. Then -2 x plus 4 minus 2i. And then last but not least, -i times each of these. So -i times x is negative xi. -2 times, or -i times -2 is positive 2i. And then the last one, negative I squared. I squared is just 1. So let's combine some like terms here. So we have x squared. We have a -2x and a -2x. So it's going to be -4x. And then xi and -xi, those cancel. 2i and 2i, those cancel. So we're left with negative I squared. I squared is just -1. So this is really going to be +1 is what's happening here. So 4 plus 1 is 5. All right, this is going to be times x plus 2. Distribute everything. X cubed minus 4x squared plus 5x plus 2x squared minus 8x plus 10. Combining like terms, we're going to get final answer is going to be x cubed minus 4x squared. Well, 4 plus 2 is 6, actually. So it's going to be, well, -4 plus 2 is -2. -2x squared is what that is. And then x's. So 5 minus 8 is negative 3x plus 10. So there's my polynomial function of least degree with the given zeros. Okay. Number 17. For the polynomial y equals that, what is the greatest number of turns the graph could have? So I'm going to look at the degree. Degree is 6. Number of turns, 1 minus that number. So the most it could have is 5. Like 5 turns. That's the most it could have. Okay. All right, that's the front. Let's look at the back. We're almost done. Fresh page. Let's go. All right, 18. Graph below a quintic, so x to the 5th power, function with zeros at negative 3. 1, 2, so negative 3, negative 1, positive 1, and 2. Multiplicity of 2. So that means that this root 2 is squared. It's going to be shown up. It's going to show up twice, meaning the graph is going to bounce. So graph below a quintic function. All right. So I know it's going to bounce at 2, right? Let's handle that part first. So that means at 2 is going to bounce like this. At 1 is going to cross. Negative 1 is going to cross. And then negative 3 is going to cross. So the end behavior, this guy's going to go down. This guy's going to go up. And then look, so we can kind of, in the middle, you can sketch. It doesn't have to be precise, right? Because we don't know these exact. Does it really cross right there? I don't know. So here's a graph of what it could be, right? X equals negative 3, it has to cross. Check. X equals negative 1, it's a root, it crosses. X equals 1, it crosses. At x equals 2, the multiplicity is 2. Multiplicity meaning there's another x equals 2. So at 2, positive 2, x equals positive 2, this thing is going to bounce off of the x-axis. It's not going to cross. It bounces. Okay. That's 18. Number 19. List the possible rational zeros. Okay. So we look at 12. We're going to take all the factors of 12 and put them over all the factors of 4. So what this means? That means factors of 12, 1 and 12, 2 and 6, 3 and 4. And these are all plus or minus. All over factors of 4. 1 and 4, 2 and 2. I'm just going to write it once. So now I got to take 1, like each of the top over each of the bottom, plus or minus. So this is going to be, I guess for your notes, this is P and this is Q, I believe. I always mix those up. So you might want to check that. P. And then this is going to be basically P over Q. That's what we're doing. All the factors of P over all the factors of Q. So this is going to be all the top numbers over 1. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 12. Now all the top numbers over 2. So plus or minus 1 over 2. 2 over 2 is 1, which is already on the list. Plus or minus 3 over 2. Plus or minus 4 over 2, that's already on the list. 6 over 2, that's on the list. 12 over 2, that's on the list. So then each of the top numbers over 4. Plus or minus 1 over 4. Plus or minus 2 over 4. 2 over 4, that's on the list. No, 2 over 4 is 1/2. 3 over 4, plus or minus 3 over 4. 4 over 4, that's on the list. 6 over 4, which is basically 3 over 2, which is on the list. And then 12 over 4, which is 3, which is on the list. So here are a list of all the possible roots. So I guess if we actually read the question, how many possible positive roots can it have? Okay, so how many total roots is it? So this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 positive roots, 10 negative roots. $20 altogether. Right, these are the possibles. I mean, is it possible for it to have no positive roots? I mean, probably. But for the most part, from this list, given this list, right? 10 positive and 10 negative. Okay, number 20. What is the y-intercept? Easy. -15. Right, because that's when x is 0. When x is 0, it crosses the y-axis. When x is 0, that's 0. When x is 0, that's 0. When x is 0, that's 0. So what's left? Y equals -15. That's the y-intercept. When x is equal to 0. Right, x equals 0. Okay, sketch the given function. Let me erase some of this. Okay, so let me write it up here. So x plus 3 squared, x plus 1 cubed, x minus 2. Okay, we want to sketch this guy. Okay. So the roots are x. So x equals 0. That's a root. Right, when x is by itself out in the front, that's just x equals 0. X minus 3. So if each of these are -1, 1, 2, 3. So x equals -3. Because it's a square, we know it's going to bounce. And these are all positive. So let's just think for a moment. What would the total degree of this thing be? So x to the 1, this would be squared, so x3. Like I'm adding up all the x's, right? Since there's going to be, so 1, 2, 3, 4, 5, 6, 7. So it's a 7 degree, which is odd. And it's all the x's are positive. So I know it's going to come from -infinity and go towards positive infinity. I know it's going to do this. So this x in the front is x equals 0. X minus 3 is going to bounce. It's going to bounce. Since it's coming from -infinity, it's going to bounce down. And then x equals -1. Right, that's an odd number. Right, this was even, which says bounce. This is odd. It says cross. So it's going to cross. And then it has to come back down, right, through 0. And then x plus 2, it has to go back up. Right, so where it crosses and where it bounces. So putting it all together, it's going to come up like this. bounce, come down, turn around, cross, turn around, cross, turn around, and then go towards infinity. It's kind of interesting, huh? That you can look at the roots and know what the graph is doing, like how it's behaving, just based off the roots or factors rather. All right, we've arrived at the last one. Let's go. So use the graph to find some roots of the function, then find all the roots. Okay, so this is saying negative x is -1 and x is +2. So -1 and +2 are the numbers I'm going to put in the little box for synthetic division. That's how I'm going to find it. Notice there's 5 terms. There's really no way of factoring this without. So synthetic division is the way. Right? If this was 4, we could split it down the middle and then factor out the GCF. But we can't because we have odd number. So let's do synthetic division. So let's start with 2. It says 0, so I'm expecting a 0 remainder. And all the x's are there in descending order. So 1, 2, -2, -9, -6. Bring down the 1. 1 times 2. When we add, we get 4 times 2 is 8. +6, +6. Times 2 is 12. Plus -9 is +3. Times 2 is 6, which is 0, as expected. I'm going to do it again with 1. -1. -1 is what's in the box. Right, because -1. Okay, synthetic division, bring down the 1 times -1. When we add, we get 3 times -1. When we add, we're going to get 3 times -1. -3, when we add, we get 0. Again, as expected. So this was x to the 4th. This is x cubed. This is x squared. So x squared plus 3x plus 3. You can't see it. Multiples, so let's factor this. Multiples of 3 that add up to 3. Can't do it. It's prime, right? 1 and 3, no way to make 3. So quadratic formula is the way. So this is going to be -3 plus or minus the square root of b squared, so 9, minus 4 times a times c. 4 times 1 is 4 times 3 is 12. All over 2 times a. Okay, so simplifying, we're going to get -3 plus or minus 9 minus 12 is -3. So negative inside the square root, that's going to come out as an I. Right, 9 minus 12 is 3. All over 2. So the two roots, other than the ones that they gave in the picture, right, are going to be, the roots are x equals -1, x equals 2, x equals -3, plus I root 3 over 2. It's a complex number. And x is equal to -3 minus I root 3 all over 2. So here are my 4. Let's go. Good luck.